Take a bottle of carbonated soda and shake it vigorously, and you create a trap. The dissolved gas inside rapidly expands, and when the pressure gets high enough, it violently forces its way out through the narrow neck. Now, scale that reaction up to the size of a planet. The solid rock we live on is incredibly thin, a fragile shell wrapping around a massive, highly pressurized system. Curious, leaning in, what physical forces are churning deep underground to generate pressure capable of breaking continents? And how does that immense energy finally puncture the surface? The ground beneath our feet serves as a temporary lid on an extremely active geological pressure cooker. This Earth cross-section strips away the crust to reveal the mantle. Here, extreme temperatures melt dense, solid rock into a glowing fluid called magma. Being lighter than surrounding rock, this magma separates and floats upward. Pushed by the heavier material sinking around it, the magma begins a relentless vertical migration toward the crust. The Earth's interior operates as a continuous density elevator, constantly pushing volatile, superheated rock toward the surface. Suspended inside the rising magma are dissolved gases, water vapor, carbon dioxide, and sulfur dioxide. As Earth's confining physical weight decreases, these gases separate into bubbles. They violently expand, forcing the magma to swell and push upward. This expanding mixture ultimately hits a bottleneck just beneath the Earth's crust, pooling into an area known as a magma chamber. And the moment that molten material breaks into the outside world, geologists give it a new name: lava. The explosion we see at the peak is the inevitable mathematical climax of a gas expansion process that started miles underground. Looking at a map of the Earth's tectonic plates explains why the surface doesn't simply burst at random. Eruptions happen almost exclusively where the crust is structurally compromised by these massive fault lines. At convergent boundaries, two plates directly collide. One heavy plate is forced underneath the other, dragging rock down into the heat of the mantle, where it melts and fuels highly explosive surface eruptions. These violent collisions define the perimeter of the Pacific Ocean basin, creating the dense network of volcanoes famously known as the Ring of Fire. Alternatively, at divergent boundaries, plates slowly pull apart. This opens a massive gap, and magma rises quietly from the mantle to fill the empty space and form new terrain. There are a few rare exceptions called hotspots. Here, an intense plume of mantle heat burns a hole straight through the middle of a shifting plate, creating isolated volcanic island chains like Hawaii. A volcanic eruption requires an exact sequence of physical events. Intense internal heat melts the rock, expanding gases fight for space, and shifting tectonic plates provide the final escape hatch.